Hello and welcome to Maths Learning. In this video, we will learn how to rationalize the denominator. When we refer to rationalizing the denominator, what we are intending to do is to remove the surd from the denominator of the fraction. A surd is a root of a positive number whose answer is irrational, like root 2, root 3, root 5, etc. The questions that you will most likely be presented with are questions involving a single surd or a mixed surd, or an expression involving a surd and a number. There are two main principles used in rationalizing the denominator. The first principle is that if you multiply a square root by itself, you'll be left with a number. So that principle is used in removing the square root. The second principle used is the difference of two squares. If you multiply a plus b by a minus b, so the signs are different, the answer is a squared minus b squared. So if either a or b were a square root, then the square root would be removed because, as stated in the first principle, squaring a square root removes the square root. Lastly, since we're dealing with fractions, to keep the fraction the same and unaltered, whatever is done to the denominator must be done to the numerator as well. So let's put all of this into practice and work through some examples. Here is a single term, 3 over root 2. So here we use the first principle and multiply the numerator and denominator by root 2. That will give us 2 as the denominator, and 3 times root 2 is 3 root 2. So we have rationalized the denominator by removing the surd from the denominator. It doesn't matter if the result is a surd in the numerator, since we are rationalizing the denominator. The fraction is still the same because we multiplied the numerator and denominator with the same term. Now here is a mixed surd. 3 over 3 root 2. We concentrate on the root because that is what we want to remove. So again, we multiply the numerator and denominator by root 2. That gives us 3 times root 2 times root 2, which gives us 3 times 2, which equals 6 as the denominator, and 3 root 2 as the numerator. Here we have an expression containing a number and a surd. We cannot just deal with the surd here, because if we multiply by root 2, we have to also multiply the number by root 2 and the surd will remain. In such cases, we use the second principle of the difference of two squares. So here we multiply the denominator with the same expression but with a different sign. The denominator is 3 take away root 2, so we must multiply it by 3 plus root 2. By the principle of the difference of squares, that gives us 9 take away 2, which equals 7. You do not need to work it out by expanding it because you know from the principle of the difference of two squares that the answer will be a squared minus b squared. So 3 squared take away root 2 squared gives us 9 take away 2. Make sure that you fully understand what number is a and what number is b, and remember that squaring a negative number makes it positive. The numerator, however, is not the difference of two squares, so you'll have to multiply it out and simplify it. Taking one term at a time, 1 times 3 equals 3, 1 times root 2 equals root 2, root 2 times 3 equals 3 root 2, and root 2 times root 2 equals 2. We can simplify the middle terms. Root 2 plus 3 root 2 equals 4 root 2. So the numerator becomes 5 plus 4 root 2. We would do one more equation. Here we have a surd in an expression contained within brackets which is squared. In such cases, multiply out the bracket first and simplify before using the principles as before. Now that the denominator has been multiplied out and simplified, you can see that it's in the form of the questions that we have already covered. Once you have completed the answer, you may have to simplify it further using the rules of surds. A question may also ask you to put the answer in a certain surd form, so make sure you know how to manipulate surds. Lastly, hopefully you found this video helpful, and if you did, give it a thumbs up, and don't forget to share, comment and subscribe, and I will see you in the next video.